Hello, so this is your very short lesson on addition of ordinates. We have looked at this before, but today we're looking at it with regard to circular functions. So here's the example. I'll give you a moment to read it. So let's start with the first function we're given. Looks like this. Obviously, you would never write pi over 2 like this. It's just how Desmos does it. Then the graph of 3 times cos 2x. Hopefully you should expect that it looks like this. Important points are included there. Now, let's think about how we're going to use addition of ordinates. Now, there are plenty of parts of the graph where we know the exact value. So we can draw up a table of values so we can find some points on the graph of the sum of these two. So I've chosen, well, you can see what values of x I've chosen. Every pi on 2 plus the first pi on 4 to get me an idea of what the beginning of the graph looks like. So I just list the values for the y1 graph, the red one, list the values for the y2 graph, then add them going across to find the y coordinates for this graph that's going to be the sum of these. So let's plot these points. So I've got the point 0, 3, and that's here. Now, if you have a look, of course, I would expect that to be the case. My green graph is at 3, my red graph is at 0, so when I add them together, it's just going to be where the green graph is. Similarly, for pi on 4, my green graph is now at 0, my red graph is at root 2, so it's just going to be where the red graph is. Moving across to pi on 2, my red graph is here at 2, the green graph is down here at -3, so it's going to be here. I'm going to skip forward. They're both symmetric from 0 to pi on 4 and then from pi on 4, 0 to pi on 2 and then pi on 2 to pi. So this is just going to be reflected. So at pi, I'm going to have 3 plus 0, which gives me 3. Now it's going to change as I move past pi. My green graph repeats the same period again, but my red graph does something different. So at 3 pi on 2, the function is going to be all the way over here, all the way down here. These parts you could also work out. We know it needs to go through this point here and this point here because my green graph is at 0. I know it's going to end up over here because my red graph is at 0. So join everything up and I get this. So the purple line is my addition function. Now I'd just like to point out, can you see that it rises up a little bit? The local maximum of the purple graph both here and here is higher than the local maximum of the green graph. Now that's because my green function starts decreasing slowly and then speeds up, whereas my red function is increasing more quickly. So we have these little extra bumps here and here. So be careful about those situations. Okay, so now you can have a go at the one question from exercise 6H. Thank you.